Hello everyone, and welcome to my brief presentation on ICS, Scada, and Cikr. It is the goal of this presentation to provide you with a passing familiarity on what these acronyms are, be able to cite examples of each, and understand the importance of the connection between them. So, what is ICS Scada? The acronyms stand for Industrial Control Systems and Supervisory Control and Data Acquisition. What that means is they are devices ranging from simple control panels and sensors that operate valves and other industrial equipment to networked computers that are able to operate and monitor industrial systems while being accessed remotely. They are two parts to the same whole and are often confused with one another. So a simple device to remember is all SCADA is ICS, but not all ICS is SCADA. The difference will become more apparent in the next few slides. Industrial control systems are simple. They can be programmed to automate certain tasks, monitor sensors, or operate industrial equipment. Supervisory control and data acquisition, otherwise known as SCADA, systems do everything ICS does, but instead of individual panels of controls, all the sensors, valves, and other equipment are networked to a computer terminal where things can be modified remotely. The networking and remote capabilities are what distinguish SCADA from simple ICS. And in the visualizations here, you can see a control center for a SCADA system, as well as a graphical representation of all of the systems that you can control from a SCADA system for, I believe that is a water treatment plant. So what you're saying, we now know what ICS SCADA means. Well, those control systems we just discussed are used in power plants, flood control systems, refineries, water purification and waste treatment plants, rail and traffic control lights, steel mills, and nearly all forms of industry. Which brings us to Critical Infrastructure and Key Resources, or Cikr. The Department of Homeland Security defines Cikr as assets, systems, and networks, whether physical or virtual, so vital that their failure or destruction would have a debilitating impact on security, continuity of government, public health and safety, public confidence, or any combination thereof. Critical thing to take away here is that failure or destruction of a Cikr would be debilitating to the United States. Here are just a couple of examples of Cikr. I've grouped them so you can see how they are linked. On the left, you have a power substation as a piece of infrastructure, but to produce that power, you need resources, such as uranium, for a nuclear power plant. One that is a little less obvious is telecom equipment as a piece of infrastructure, but the communications and data passing over that infrastructure is listed as a key resource. So now we know what critical infrastructure and key resources are and how they are linked, but how are they linked to ICS SCADA? Well, ICS SCADA controls Cikr. They are all part of industry. SCADA systems usually do not have security built into the software, and some are able to be reached via the internet because they are networked together. If a malicious person were able to access these systems, they could cause them to fail or even be destroyed. Remember, failure or destruction would be debilitating to the United States. And here we have a list of the categories that DHS considers critical, as well as DHS visualization for implementing a protection plan. DHS has a copy of the National Infrastructure Protection Plan on their website for anyone who wants to look at it more in depth, and I have provided a link in the reference slides that follow. Thank you for viewing my presentation.